Okay, welcome everyone. Let me share my screen and talk about the plan for the day. So this is the week 1 webinar, I call it. It's our first regular webinar. I know we had a webinar last night, but this is the first one where I actually talk about statistics. Okay, and I want to give an apology just in case. If all of a sudden the whole thing turns off, we're in the middle of a blizzard right now if you're not in Tahoe, and who knows what'll happen in terms of internet and electricity and all that stuff. But so hopefully for the next hour and a half or so we'll be good and we won't have any of those issues. But I do want to give a heads up just in case here, just in case you can't see. That's what it looks outside. In case you're not in Tahoe. If you're in Tahoe, then you look out your own window, you see the same thing basically. So I figured I should mention that. Fortunately, we're open. I heard the K-12 is all closed, but the college is open, and which means I will be in my office hours today. But again, drive very carefully if you come here. You're always welcome to Zoom in, and as long as internet and power's on, then I'll be on my office hour Zoom. So just note those things. So in terms of the plan today is our first webinar where we actually do statistics. Last night we had the orientation webinar, and that's totally different. That's just talking about the course and that's it. This one we're talking about statistics, and in particular, we're going to be doing chapter 1 and chapter 2. I always have this as number 1, but it's number all. And that's Q&A. So anytime you have any questions, that could be the beginning, it could be in the middle, it could be the end, post in the chat box, ask it whatever it takes, and I'll be answering the questions. So that is something to note. Then we're going to look at sampling techniques, and we're going to be looking at kind of survey design, because that's a big deal. What happens is you can almost never survey the entire population. So if you want to, find out what the average anything is of people on Earth, you can't, because you can't survey everyone on Earth. By the time you finish, there'll be 7 generations done and there'll be new people on Earth. So you just can't do it. So what you do is you do a survey, and use a survey to provide good estimates and a really nice educated guess on what the population looks like. Okay, and most of what I talk about is people, but it doesn't have to be people. It could be, you might be surveying dogs, and you want to find out, I don't know, how many times a day does a dog poop or something? Who knows? It may not be about people, or it could be, the height of pine trees in the Sierra Nevada forest. So just because most of my examples are going to be surveys of people, it doesn't have to be people. Just let you know, it's just any data you might be collecting. And we'll be talking about the sampling techniques, because again, you can almost never get everybody. So then you got to say, well, I only have so much time. So how can I best use my time so that those that I do survey, I actually have a good representation of society, and I can use that to make informed decisions. And really, that's what you want to be able to do. And we'll talk about good techniques, bad techniques, and techniques depending on the situation. Then we'll get into, I know this is like the name of the class, but it's really important, and that is statistics. Statistics is the name of the class, but also it has a specific meaning, and that is once you collect your data, especially if it's quantitative, which means that you grab a lot of numbers, then you want to find the average. That's a statistic. There's a whole lot of other statistics that will help you understand that data that you collected. And that's what we'll be looking at. Then we'll be looking at charts. And you've seen some of these charts, things like a bar chart or a pie chart. I'm sure you've all seen those too. But then there's others too that you may or may not have seen or may not have understood. And that's like a box plot. That's something that is an important one in research. It tells a lot, but it's not something a lot of people know about. And then there'll be stem and leaf diagram. We'll look at histograms and possibly others. Then we'll look at z-score. And that is a measure of how unusual something is. And I'll get into that when we get there. And then finally, we might be talking about variables, different kinds of variables that might happen. And I'll have lots of examples. The thing I love about this class is it's so easy to grab an example from whatever's happening today. Okay, just go online, go to the news, and I can find statistics in a second. It's so great. And whereas that's not true of most classes, but this class, it's easy in just about everything we do every week. It's that important. So I'll be talking about all the different things you can do with this stuff. So are there any questions about anything? Okay, it could be about something that happened in the orientation, could be about something and you were trying to get into Canvas for something and you couldn't find it, or could be, I don't know, anything else. Any questions? Okay. If you don't have any questions now, I just want to let you know if questions come up, please ask. So please ask throughout the class. And that's the whole point of doing a live webinar instead of a not live webinar where it's just me recording a lecture, which I have a lot of those too. But this way you can ask questions and we can interact. And we will interact, by the way. We'll be doing some statistics on you guys. Okay, is the way I do it. And I'll do a lot of that. Okay, so let's talk about, let me give you an example. And we'll talk about, whether it works or doesn't work. So I like to, if I can bring local stuff, if there's nothing giant in the news, the giant thing in the news locally, and you all know it who are in Tahoe, and that is, it is snowing a lot right now. So the big question is, and this is the Tahoe Daily Tribune, by the way, and if you look at the Tribune, they have a survey. And their survey is, what is your prediction for the precipitation totals this winter season? And the answers are, it's going to be a monster snow season, above average, below average, or we're not going to escape the drought yet. So put in the chat box what you think, just for fun. And then we'll take a look at what the results are. Okay, and notice as you're putting the chat box, I want to mention something is that the answers are words. The answers are words. This is not a yes/no question. And this is also not something where you're going to say 73 for your answer, right? Your answer is going to be above average, or it's going to be a monster snow season. Okay, and I'm seeing a lot of you type in above average and monster snow seems to be the answer to y'all. Okay, let's see what happened for those who answered in for this particular poll on the Tribune. This isn't you all. This is whoever posted it. Okay, and by the way, there were 627 people who answered this survey. Okay, and let's just, and this may not be perfect, but let's say this is Tahoe Basin people. That's mostly who's going to be answering or who's going to be looking at the Tahoe Tribune. There could be some tourists and stuff too, but mostly it's Tahoe Basin people. And there were 627 Tahoe Basin people that answered, and it looks like above average is the most common. Okay, at 33% of the votes. We're not going to escape the drought yet. And that's 25%. By the way, monster snow season, which a bunch of you said, that was not very many. That was the smallest percent of the group, for the smallest number. All right, so here we have it. So I want to think about a few things. One is, and we're going to note this later on at the very end when we do variables, we'll talk about this. And that one of them is 627 people voted. Is that the whole Tahoe Basin? And if you're not from Tahoe, you may not know, but you probably do know. Is that everyone in all of Tahoe? Okay, it's not even close. Okay, it's not even close. There's like 50,000 people that live in the Tahoe Basin or so. I don't know the exact number, but somewhere around that. It's something like 25,000 in South Tahoe. So I'm figuring we're about half ish, might be 40,000 because I think we're a lot more than half. But it's not everyone. Could they have gotten everyone? Think they could have gotten everyone to vote? Would it have been possible?
Probably not.
Yeah, it's definitely not possible. How would they find everyone? Right, good luck. Good luck. Tell those people that you can't even search and find. You know what I mean? There's people that are out of town and they won't be able to get a hold of them. There's who knows, you know. In the summertime, for example, sometimes they can't get me. And you know why? That I am unreachable for like a week at a time sometimes. So I'm one of them that sometimes you can't get in the summer. This time of year you can because I'm teaching. I backpack. And I'm totally off the grid. Good luck finding me in the middle of the forest somewhere. So there are people that are just not findable. You're not going to be able to get everyone. Even if you could find everyone, it's just too expensive because you got to pay someone to do the survey. So they did this. Okay, so this is a sample instead of a census. So a census is when you asked everyone, and a sample is when you asked some of the population. Any questions on that? And I do want to remind you, it doesn't have to be people. Could be measure every tree, but you get the idea, hopefully. So that's a big deal. And in the real world, the census is not often done because it's too hard. It's not feasible. So samples are what people do. So then the next big question is this a representative sample? Do you think the people that answered this survey is a good representation of the entire population of the Tahoe Basin? Or do you think, and this is a statistics word, or do you think it's biased, which means the type of person who answers a survey online is likely to have different answers about what they feel about the precipitation totals this winter season? Or do you think the type of person that tends to answer online is just like everybody? There's nothing special about them in how they might answer. Okay. And I'm seeing some of you in the chat box saying biased, and I think it's probably biased. I don't have a good feel for exactly how it's biased. Like I really don't know. I really don't know. But what we call this is the bias. One of the biases would be voluntary response bias, which I see in the chat box. And that means that this is a survey where you get to choose whether you want to answer or not. So it's totally voluntary. Okay. The sampling that's done on this is called convenience sampling, which means they just threw something up and whoever happened to answer whatever's convenient, that's what they grab. Does that make sense? So you don't do this for scientific research ever, okay? Or you shouldn't, because it is prone to a lot of bias. Convenience sampling is not a very good way of doing studies. Does that make sense? Okay, sometimes it happens, but everything you can try to do, you should not use convenience sampling if you can. Any questions in this idea? All right, so now we can go back, and now we're going to talk about different types of sampling. Okay, and let me talk about variables too, because we talked about that at the very beginning. So there are different, our sample size for this one, let's copy and paste from last time, 627. There are three kinds of variables that can happen. Okay, three main, there are different types. There's two types, and within those types, there's different types. So there's qualitative and there's quantitative. So qualitative means that the answer to the survey question is just a word. Whereas quantitative means the answer to the survey question is a number. So in the survey about the, this winter season, was that quantitative or qualitative? See if you can tell me in the chat box. What do you think it was, qualitative or quantitative?
Quantitative?
Okay. I heard quantitative, but it's qualitative because the answers, this one, the answers are above average. We're not going to escape that drought yet. That's not a number. Okay, below average, that's not a number. And it's going to be a monster snow season, also not a number. Do you see that? Those are words. This is a very clear example of qualitative because the answers are words. Any questions on that?
No.
Can you say or put in the chat box an example of a survey question that is quantitative? And there's a lot of them. So what's an example of a quantitative survey question? It's not a trick question. It shouldn't be that hard. There's lots of survey questions you could ask someone, okay, or do something to and get a number out of it. Oh, good. How much does the snow weigh? Okay, that might be in your driveway or something like that. And that would be a quantitative survey question because the answer to that might be, in my driveway, not much anymore, but before I shoveled, before I got here, it was probably, 500 pounds or something. It was a lot of snow. Okay. How tall is each person or how tall is each person in the class, or how tall are you is probably the survey question, right? Does that make sense? So the survey question would be, how tall are you? And the answer to that for me would be 70 inches. 70 inches. Okay. Any questions on that? Or if you want to do it in feet inches, because most people know that better, it's 5'9", 5'9.5" or 5'10". Okay, which is a number. How fast can the average adult run? But better would be how fast can you run a mile? Do you see that? Because then the answer to that would be a survey question. How fast can you run? Okay. And that might be, I don't know, 5 miles an hour if you're slow, or 8 miles an hour. Whatever. I was a marathon runner, but I was never into winning, so I never cared how fast I went. So sorry if I don't know how fast runners go. Okay. But do you understand that it would be a survey question where the answer is a number? And there's many, many of those. The good thing about when the answer is a number is you can do statistics. You can do math. Whereas with words, there's not as much math you can do. Does that make sense? You can take an average of all the answers. You can do that with numbers. You can't take the average of the answers to this Tahoe Tribune survey question. Do you see that? The average of these 4 answers doesn't make any sense. So if you can, it's better to do a quantitative survey. And just to let you know, in your project, you have to do a quantitative survey for that reason, because then you can do a full analysis. Okay, we're not quite ready to do the full project description, but I can say that and give you hints about the project. Okay, any questions about that so far? All right, so they use convenience sampling, as I mentioned, and that is you survey whatever's easiest, whatever's convenient. And in that case, whoever answered the survey question online and whoever happened to, click it. But that's not the best. So here's a thought. Okay, this is one. It's going to be too much typing, so I'm going to have you think about it. Is let's suppose instead of convenience sampling, you actually really wanted to find out a good estimate for what people think about the snow season this winter in Tahoe. And you don't want to use convenience sampling because that's prone to a lot of bias. So what we want to do is we want to think about how might you conduct a study so that you can avoid some of the bias. Any questions on my question? Okay, and by the way, it's a very difficult question. Okay, and it's difficult because it's real world, and doing things in the real world is hard. Just let you know that. Conducting real studies is not easy, and preventing bias is really hard. Okay, but what you can do, you can't prevent all bias. That's almost impossible. But maybe you can limit the bias. You can make maybe less bias than convenience sampling. And that you can do. Any questions on the idea of the goal? Okay, so the most common way of doing a scientific study so that you do your best to prevent bias is you do what's called stratified sampling. And this is a step-by-step, 4-step process. So let me make it bigger so you can see it. And here's how it works. Okay, and I do want to remind you, this is all recorded. And in fact, I don't know if any of you noticed, but the last night's video is on YouTube now. It was on last night, actually. So this will be on this afternoon. So if you didn't write out everything, you can always go back and look at it. Okay. So step 1 is you identify the strata which break the population into groups. And in particular, that might help you eliminate bias. Okay. So in this case, you might think age might be a bias. Old people might have a different way of, thinking about the weather, the winter season, than younger people. Does that make sense? So what you would do is you would say, well, let's break it into groups. And I want to mention something. You almost always want to just get rid of everyone under 18. Anyone know why? There's a reason. Not because they're not important. They're important people. But why in a scientific study you just get rid of everyone under 18? Yeah, you need consent because you get sued up your behind, and lawyers will take you down. So, and let you know in the projects, you are not allowed to survey children because I don't want to get sued. Got it? Okay. And again, we're not quite ready for the project, but I'm going to mention that multiple times. No surveying children. So let's think about if you're doing age groups here, maybe 18 to 29-year-olds, kind of the younger group in that way. Maybe 30 to 50 and 50 and up. Okay. And again, you could break it up differently, whatever you felt would be a good way of breaking up the age groups. And that would be your first step, is you decide on the groups that you're going to break up the population. Okay. And it could be age. Another one that's often done is race or ethnicity. That's often for people, by the way. Another one would be income, because people with income might have different, attitudes or whatever. College education could be another one, how educated you are. Another one that's often used besides any of those might be the type of place they live in. So they live in an apartment or a house, or, homeless, or, that could matter. There are many, many types of strata, is what we're going to call it, that you can decide on. Okay. In our class, we're going to keep it easy, and we're just going to pick one. Okay. In the real world, you pick several strata and you make sure everything's perfect for all of them. But for your project, you're just going to pick one, and all my examples, I'll just do one. Otherwise, it's too complicated. Remember, the title of this class is Elementary Statistics. I can't do the advanced stuff. Okay. So step 2 is research the percentages of each group. Okay. So that, in that case, what I would probably do is go online and probably go to Google and type in what percentage of people are under 30 in the Tahoe Basin, or between, of adults are under 30 in the Tahoe Basin. What percentage are between 30 and 50, et cetera. Does that make sense? And you do that research. Okay. In the old days, that was really hard, but now we have something called the internet, and research is so much easier. Okay. So that's what you do. But you have to do that. Okay. Step 3 is you multiply the percents by the sample size to establish quotas. So let's suppose that we're going to mimic what they did, 627 votes. So let's suppose we did our research and we found out that, let's say 30% of the population, I'm just making it up, so don't quote me, 30% of the population is between 20 and 30 years old. So then you take 30% of 627, round that to the nearest whole number, because you got to ask people. And that is your quota for the people between 20 and 30 years old. And then you say, let's say that, I don't know, 25% are between 30 and 50. So then you take 25% of 627, and that'll be your quotas for between 30 and 50. Do you see that? And then you do that for the next group. So you do that for each of the groups, and you establish your quotas. So is there anything you don't understand, please ask. Okay. And remember, just to remind you in case you forgot math, if it was 30%, and let's say it was 627, the math you do is 0.30 times 627. That's how you do percentages. So you got to take that percent and turn it into a decimal, and then you multiply. So there's a little bit of math in this class, but nothing too advanced. Hopefully you agree that's not advanced. That's how you do percentages. Okay. And then finally is you conduct your survey and ensure that you ask exactly the quota amounts. Okay. So let's suppose we ended up with, I don't know, 190 20 to 30-year-olds you need to ask. And let's suppose you got your 190, and then you got to the next person, and the first question is, what's your age? So you can decide where they belong. And if they say, I'm 25 years old, you say, thank you, but I'm not going to ask you the question because you already got your quota. Do you see that? So you just keep asking until you've established quotas in each, and then you have your collection of data. And what you've now done is you have eliminated age bias by doing this, because you've made sure that the ages of the people you ask are representative of the population. Okay, so like I said, you think about what might be a big bias, and that's what you use for your strata. Any questions on stratified sampling? Okay, it's pretty complex, but it's the most important one. It comes up more than any other sampling technique. Okay, and when I say it comes up, I mean for kind of research-oriented studies, or scientific studies. Convenience sampling is probably the most common, but you should never trust convenience sampling. But for trustworthy studies, stratified is the most common because it allows you to prevent certain biases. Any questions on stratified sampling? Okay, the next one. The next one is called random sampling. You've all heard of it before, right? All right, I have a question for you. Let's see if you can do it. Pick a number, a whole number between 1 and 10, a random number. Pick a random number between 1 and 10 and put it in the chat box. Okay. It turns out that you didn't do what I asked you to do. This is kind of a mean question. And the reason is not math, it's actually psychology. Is that humans don't have the ability to pick random numbers. Is that we tend to be biased in our brains. So if I ask you to pick a random number and you think you did, you didn't. Okay, and they've done lots of studies where they'd ask that, and then people can't do it. You don't, because if it's truly random and you ask 1,000 people, then you should have 100 ones, 100 twos, 100 threes, 100 fours approximately, right? And it's nowhere near that. So just let you know that that kind of randomness doesn't work. So, but the nice thing is nowadays it's really easy to get random numbers, which is how do you truly get a random number between 1 and 10?
Your random number generator thing.
You could use mine. Yeah, mine's not the easiest, but mine's easy. The easiest for most of you. And you can try it right now if you want. And my guess is you've got it in front of you. Is just ask your smartphone, give me a random number between 1 and 10. And try it, and it'll give you one. They all do it now, if you just say it. And it'll give you a random number, and that actually works. Okay, so what random sampling means is the following. It means that the first thing you do is you have to order the entire population into then use a computer. And by the way, when I say computer, it could be smartphone too. It could be a computer to pick n random numbers. From 1 to the sample size. Actually, I shouldn't use n. How about k? Is that a letter? Sample size is always n. That's why I didn't want to use m for. I'm sorry. No, I'm sorry. It's that was right. N, capital N. It was n. My mistake. Okay, so the sample size is n. Capital N will be like the 50,000 if it was the population of all of all Tahoe Basin. The hard part, what's the hard, and then survey the selected individuals. Sounds easy, doesn't it? Easy to type. There's 2 hard parts, and usually impossible, by the way. You know what they are? All right. First part is this one right here. Order the entire population. Do you really think you can get a list of all people in the Tahoe Basin? No. No. I think the sheriff can. So you might, if you're a hacker, you might be able to hack into their system and illegally get a list. But don't do that, by the way, please, because that's against the law. So most populations actually it's not possible, and not legal. Possible or legal. So if it was say trees, because that's legal. But do you think you could order all trees in the Sierra Nevada basin? Oh, are you kidding? There's billions and billions of trees. You couldn't get a list of them because there's just too many. It would be too much work. Does that make sense? Even with a satellite, forget it. Okay, so that's usually impossible because populations are usually too big. Okay, this one is very possible. Use a computer to pick the n random numbers. That's no problem. If you can do the first part. The third part is usually impossible. And that is survey you got to survey the selected individuals. So if you pick the 627 individuals, let's say you did hack into the sheriff's system and got the 627 people, then you had to go find them all and get them to answer your survey question. Good luck. Do you see that? So random sampling is for big populations is impossible. There are times when it is possible. So if you want to randomly sample, say, a classroom of 30 college students, you want to pick 5 students, that you could probably do. Because you can get a list of the 30 students and stick it in a computer, grab 5, and then go talk to the 5 people. Okay, but when you have large populations, it's almost always impossible. So random sampling, good luck. If you think you did it for your project, I want to see a whole paragraph explaining that you did it and showing how, and I'm not going to believe you. Just let you know that, because you can't. Okay, so now the next one is done a lot, and that is cluster sampling. This is done especially in colleges, actually, okay, but a lot of other places too. So this one has a kind of a step-by-step process. The first step is to break the population into many, many clusters. Okay, and that would be many, many groups. And we're not talking about 3 groups. We're talking many, many groups. So what are the obvious many, many groups for colleges, for a college? Say Lake Tahoe Community College. What are the obvious groups? Yeah, classes. And that's really easy because you can go to the class schedule and there's several hundred classes we have, and there's your groups. Does that make sense? Another one, let me give you a Forest Service. I'm sorry if I say Forest Service a lot. I've done a lot of work for the Forest Service, helping them out with statistics, believe it or not. And so if they wanted to look at trees in the Sierra Nevada, then probably the groups that you would break that into would be acres. And you could pretty easily get a map of California, of the Sierra Nevadas, and then, little acres on that map, and those are your groups. Does that make sense? Okay, so there's lots of ways of doing groups. Groups are often by location. There's sometimes classes. They could be time. So I don't know if any of you work in a restaurant, but let's say you work in a restaurant, you want to find out what's the average tip percent that wait staff get. Okay, you're not going to be able to find out every single tip that's ever happened, right? But what you could do is you do cluster sampling, and you might cluster by time. So then you might do 10-minute intervals. Bills paid at 10-minute intervals, for example. And then those would be your clusters. Then you are going to pick a few representative clusters to survey them. So for the college idea, then you might want to pick maybe a couple online classes, maybe a couple face-to-face classes, and then make sure that maybe some of your classes are transfer classes. If it's community college, maybe some of your classes are more of the fun classes, like a cooking class or art or skiing or something like that. So that would represent the population well. Do you see how that works? Okay. And then you survey everyone in those few clusters that you chose. And then you don't have voluntary response bias because you surveyed them all. Okay. For the forest example, again, in that case, you might want to pick some acres that might be on a pretty steep hillside, some acres that are by water, some acres that are in drier areas, and maybe, pick 10 different acres. And then you go to the acres, you measure all the trees in that acre, you measure the trees in that acre, in each of those 10 acres, and then you have your data. See how that works? And it's representative, and you prevented some bias. Not all bias, but you prevented some bias. Okay, kind of already answered this one, so I don't have to do it. Any questions on that? And as I mentioned, it gets rid of voluntary response bias, because cluster sampling involves asking everyone in each cluster. There's no voluntary response issue. Okay, by the way, if you want to make sure that everyone answers, let's say you're doing a study and your clusters are maybe streets, blocks, and you got this block and you want to make sure that everyone in that block answers. How do you do that in the real world? Any thoughts? When I say it, it'll be obvious. Go door to door. Some people won't answer. The door to door could work, but the problem is not everyone will answer. So let me give you my personal example. I got a phone call. It was some years ago, saying, we're doing a survey and we're going to give you $100 if you answer our survey. What do you think I did? I answered, I smiled, and they gave me $100 for answering their short survey. It was wonderful. So that's what you do. You basically pay them. You give them some benefit. You bribe them to make sure that they answer. And that in the real world and people, that works. My guess is all of you would have answered too, had you gotten that phone call, right? Okay, knowing that it was real, by the way. Okay, it wasn't, and they did give me the $100, by the way. It was really cool. So there are ways of getting everyone done. Okay, then the next one, the last one I want to talk about is called systematic sampling. And this is especially done in manufacturing, but it's done in other things too. And there's an example I like to give because I did it. I had a student actually graduated, got a business, and his business was manufacturing towels, and he wanted to show that his towels were better than the ones made in China. And what he wanted to do is he wanted to look at his towels and then wash them, use them, and see how long they lasted, basically by pushing, and doing the same thing with Chinese ones. But he couldn't do it to every one of his towels because then he'd be out of business. You can't destroy everything you've made. So he needed to have a sample of towels to use. So what I suggested to him was he use a systematic sampling approach, and which is really easy when you're manufacturing. What that means is, I don't remember exactly, but let's say he made 10,000 towels, and he wanted a sample size of 50. Then 10,000 over 50 is 200. Okay, you could use a calculator. I have a calculator in here, but you can use your regular calculator. So I had him pull every 200th towel off the assembly line as it came off the assembly line, and use those. And that gave him a sample of 50 towels. And then he used those and saw how long they lasted. Okay, so systematic sampling means you sample every nth individual. So you have to be able to it has to be ordered. If it's not ordered, you can't do systematic. And then you can do it pretty easily. You can do it with people also, like with students. You could say survey every 100 student who registered at the college, and that would be systematic. Any questions on that? Any questions? Okay, so those are the main sampling techniques that are used. There are a few others which I only have so much time, and we can only do so much in this class, but these are the important ones. Any questions? Any questions about the sampling? Okay. By the way, which is the only one that has no bias? There's only one of the that I did on the list that has no bias at all. Now, cluster has bias because remember, you only pick a few clusters, and you can't get a perfect representation. So there is some bias in clusters because systematic can have some bias. It's complicated though on how that bias can happen. I think I can't even get into it. All right, no one's guessing. It's the one you can't do, random sampling. There's no bias in random sampling. Right? You picked a bunch of random numbers. Okay, and that's unbiased. Any questions on that for sampling bias? Just a note, since this is going to be important for your project for project 1, you have to do either stratified sampling or cluster sampling. It has to be one of those two. So pay strong attention to those two. And you get to choose. And then you have to do it right. So yeah, you're going to have to write a whole paragraph on how you did it. And it better be correct.
Which ones were they again?
Stratified and cluster. And that's all written in the project description, but I figure I should just mention it now. Any questions on sampling? I do want to let you know that I'm making it sound easy. Sampling in the real world is really hard. Okay, it could take months. Okay, one more mention I want to mention because it's a really important one And this is probably the most important study that's happened in the last 3 years. Important to most of you. You know what that one is? Yeah, what about COVID though? Something about COVID. It was a study, right? So something about COVID. Should I tell you? Okay, the vaccination. Yeah, there we go. Good. We do have someone that said it. Vaccine. The vaccine. Okay, so Pfizer and Moderna and J&J came out with vaccines. Hopefully you know that. Otherwise, you've been like hiding under a rock or something. So they came up with vaccines. Okay. Did they test everyone in the world to make sure it worked? Of course not. I didn't get vaccinated by all 3 of them. So they definitely didn't. Okay. And at the beginning, we're talking about. Okay. So I read up on it, and I won't get into all the details because it's a little too complicated. But they did a sample size of 40,000. Okay, which sounds huge, but remember, we have 8 billion people on Earth. So it's a small percentage of people, but it takes a lot of work to do a sample size of 40,000. And the way they did it is they did what's called a randomized control study. So that's one more type of sampling. So of the 40,000, and I'm not 100% sure if it was a 20,000 split, but we'll just say it to make life easier. That way, if it isn't true, then I haven't told you the wrong numbers, because I'm not sure if it was 2020. But basically, they grabbed 20,000 people to get the vaccine, and 20,000 people who they told they got the vaccine, but they didn't. They gave them a shot of nothing. Okay, maybe some water or something, I don't know. And that's what they did. And what they did is they did a randomized double-blind control study. So what that means is they took the 40,000 people that were volunteers. You have to get volunteers. You can't force people to do it. And they took a computer, and the computer selected 20,000 of those people. Those 20,000 people were the treatment group, the ones that get the vaccine. The other 20,000 are the control group. They don't get the vaccine. Any questions on that idea? Okay, the computer picks the numbers. The people are the doctors or nurses, whoever's giving the shots, are not given the names of the people. They're given ID numbers, and they're given the names of the people, but what they're given a fluid, but they don't know if the fluid is the control or the treatment, the fake or the real. So the nurses and doctors, they don't even know whether they're giving someone the real vaccine or not. So that makes it double blind. Also, the people getting the shot don't know if they're getting the treatment or the fake one. So that makes it double blind, because both don't know. And that's called a double blind control study. And that's done in a lot of medicine does double blind. They do double blind control studies. Okay. Any questions on that idea? I figured, because I know we have at least one medical professional, because I got an email from someone. But my guess, we have a whole lot more. So maybe not, but my guess, we have a lot of medical people. And in medicine, they try to do, if they can, control studies. And I was on the other side of it once. When I was a college student, so it's like a long time ago, over 30 years ago, there was an ad in the college newsletter that said, "Hey, if you got the runs, run to the hospital. We'll give you $100 and be part of our study." And as you might guess, I was having a bad day at the runs, and I went, and they gave me the $100. They gave me the shot, and it turned out I was a placebo group and I didn't get better. And the next day they apologized and they gave me real medicine. So I was personally experiencing that. So that's done a lot in medicine, that type of study. Okay, there are many, many different ways of doing studies. Any questions on that? Any questions? Okay, so now let's move to chapter 2. We just finished. It doesn't mean I've said everything you can have in chapter 1, but I only have so much time. So I want to talk about chapter 2. Chapter 2 is, now it's going to look more mathy. Okay, in fact, have I done anything that looks like math at all yet in this class in chapter 1? Maybe I did a percent of something. That was about it, but nothing mathy at all. Okay, chapter 2 is a little more mathy. Okay, but nothing hard because of the calculator. Okay, when I first taught this class, this was a brutal chapter because you had to do it by hand because there were no fancy calculators. But now you get calculators, which is really nice. So I want to talk about statistics. Okay, so this is a big definition. So let me put it in red, actually, because it's important enough. It is the name of the class. So since it's the name of the class, it must be an important word. So a statistic is a number that is calculated from the sample data. And here are a bunch of examples. Some of these you've seen. One is mean. What's another word for mean? If you want to tell, say, a 10-year-old, what word would you use instead of mean? Yeah, average. Average. Okay. In our class, we're going to use the fancy word mean. That's not too bad. Okay. It doesn't mean evil, by the way. Not that kind of mean. Okay. So it's the average. Okay. The reason why we in statisticians don't use average, a lot of times they'll use average for median also. So average could be a little confusing for some people. And this way you break it up into 2 different types of averages. And that's why. Then there's the median. Who remembers from probably middle school you learned what the median is? It might have been a long time for you. Yeah, it's the middle. It's either the middle number or it's the average of the 2 middle numbers. So if there's an even number of numbers, then there could be, there's actually 2 that are tied for being in the middle. You take the average of those 2 and that's the median. If there's an odd number of numbers, then there's one number that's right in the middle and that's the median. Okay. So it's the middle. Then there's the standard deviation. Okay. Standard deviation is the most important new one of this whole course, not just the day. Okay. You have to get this one down. And I'll be spending a lot of time on that in the next, 30 minutes or so, or 35 minutes on the standard deviation. And what it does is it gives you an idea of how spread out the data are. Okay. So for example, if you looked at, say, heights of people in Tahoe, okay, that's going to have a pretty high standard deviation compared to, let's say, the heights of people in 2nd grade in Tahoe. Because if you look at 2nd graders, they're not going to be the same height, but they're not going to be that different from each other. Do you see that? Whereas if you look at just people in Tahoe, okay, or if you don't like Tahoe, just call it California or something, doesn't matter. Then there's people that are just born, they're infants and they're little tiny, tiny ones. And then there's these giant basketball players and they're all over the place. Do you see that? So the standard deviation tells you how all over the place the data is. Any questions on that idea? And I'll have lots of examples, by the way. The next one is Q1, which means the first quartile. In fact, maybe I'll write down the word. The first quartile. So the median splits the population into 2 pieces, the top and the bottom. Does that make sense? But then if you instead want to split it in 4 instead of 2, then you can have quarters. And the first quartile is kind of the top of the lower quarter. Does that make sense? So 25% is below that number. Q3, any guess on what that might be?
Third quartile?
Yeah, that's the third quartile. Okay, and the third quartile will be, if you look at the lower 75%, then it would be the top of the lower 75%. Or if you look at the upper 25%, it'd be the bottom of the upper 25%, because that's the same. I want to give you a disastrous comment. It's the one thing in statistics that drives me completely crazy. And that is, there's no agreed upon formal definition of the calculation of these. Isn't that terrible? You ever heard of something in math where there's no agreed upon definition for how to calculate it? Okay, so sorry about that. So the one thing is, I'm not going to ask you to do a calculation by hand. I'll let you use my calculator and then just trust it. Sound good? But if you use my calculator and you use a different calculator, you might get different answers. Sorry. Because there's different formulas and not everyone agrees. Isn't that terrible? Yeah, so sorry. Okay, the IQR is the interquartile range. And that is the range between the first quartile and the third quartile. Another way of saying is it is the range of the middle 50% of the group. So you've probably heard of teaching to the middle. That would mean you're teaching to the interquartile range. That group. That makes sense? So it's the middle group, the middle 50%. Okay, and then finally there's the z-score. So the z-score is, there's a formula, which means I am going to have to use the equation in Google. And that one, I think, yep. It is x minus mu divided by sigma. Oh, let me write down z. That's z. Let's make it bigger. Okay, so let me explain what all these things are. So x is the given value. Mu is the mean. And sigma is the standard deviation. Okay, and these are the population mean and population standard deviation technically. And what the z-score tells you is how unusual something is. Okay, if the z-score is like high, and by the way, kind of high, bigger than 2 is pretty high, then it's unusually large. If the z-score is low, less than -2 is low, then it's unusually small. So it gives you how large or how small something is compared to the rest of the group. It's a really good thing to have when you don't really know the group that well. Okay, so if I told you that there was a hamster I saw that weighed 12 ounces. Now, and then I asked you, is it big or small? Or is it like a normal hamster? Okay, if you're like me, you have no idea. Because I don't know anything about hamsters, by the way. Okay, maybe you're an expert in hamsters and you know exactly what that tells you. Okay, but I have no clue. On the other hand, if I told you that the z-score of the hamster was -3, then I know it's a tiny hamster because that's really low. If I told you the z-score was, say, 0.4, then it's just a normal old hamster. Do you see that? Because that's close to 0. So that's what the z-score does. Any questions on this? Okay, let's do an example. And I want to ask you a survey question. And what I want you to do, and it's the first person who puts in the chat box, is write down a survey question that's quantitative that you could ask you, that I can ask all of you, that you might be interested in finding out about each other. And put in the chat box, first person to put it in, and we'll use that one. It has to be quantitative, so it has to be a number answer. And first person to put something that you might be interested in each other, go ahead and do that. Watch in. It might take a while to type, I know. So that's something you might be interested in finding out about each other. That's a number. Okay, all right. What is everyone's age? Or how about what is the age of people in the class? How's that? Okay, so here's the deal. You have to put something in the chat box. If you don't feel comfortable telling everyone how old you are, then just put some reasonable number. Don't put 7,000 because I know you're not 7,000 years old. Okay, and put your age or the age that you want to tell people. Just because you don't want to tell people your age, just put a number in. Just want to make sure I get all the numbers. Okay. All right, so here's what I'm going to do. I'm going to go to the calculator. This is the first time we're actually going to use a calculator to do something. Okay, so just to note, I did my best to try and make it as easy as possible to use this calculator. So I actually did things in the order at which we do things in class. So the calculator we're going to use is this number 2. I've already shown you number 1. So number 2 is one variable statistics calculator. It's just one survey question. We want statistics. And I click on that. And what it says is type in the values from the data set separated by commas. For example, 2, 4, 5, 8, 11, 12, then click calculate. Okay, do you agree that's pretty easy? I tried to make it easy. And if there's something that's not easy for you, let me know and I'll make it better, because I can, but I do my best. And I'm going to put in the numbers, 32, 18, 28, I have to scroll more, 40, 19, 29, 22, 30, 35, 22. Okay, and we have to decide, is this the population or is this a sample? For this particular example, it really depends. Okay, are we considering this a sample of all the, statistics students? Maybe online stat students in the classes, or are we considering this the people here? Okay, if we're considering it the people here, it's the whole population because hopefully everybody answered. If we're thinking of this as a kind of a representation of all statistics online students, then this would be a sample. Does that make sense? So I'm going to say, let's consider this a representation of online stat students. And I click sample standard deviation. And I hit calculate. Was that hard? Okay, I just want to give you one heads up that some people have trouble with. If you have really big numbers, so instead of if I asked you what age where you were, maybe how expensive your house is. Let's say if everyone lived in a house, and my house might be 620,533. Okay, I have no idea exactly what my house is, but let's say it was. Then I would have to type in 620,533, not 620, 533. Don't put a comma with the number, even though you're used to doing that in that thousands place, because this calculator uses commas to separate the numbers. Does that make sense? Okay, otherwise it would look at it as a house that was worth 622,000 and a house that was worth $533, and that's not what it is. Okay, so now we can go through and look at this. The mean is 27.5. So we can say is the average age is 27.5 years old. Is that easy? Okay, some of these are really easy. Minimum is 18. Well, that's easy. That's the youngest person who answered the survey question is 18 years old. Any questions on that? Q1 is 22. So what that tells us is that 25% of the students are 22 years or younger. 22 years old or younger, because that's the lower 25%. Any questions on that? The median, 28.5. So that is the middle age. The student in the middle has aged 28 and a half years old. Notice no one said 28 and a half because there were an even number of people, and that was the average of the two middles. Q3 is 32. So 75% of the population is younger than 32 years old. Any questions on that? Okay, 25% is over 32. Okay, and by the way, is it younger than 32 or 32 or younger? And that's where it gets really hard. I'm not even going to go there. That depends on who you talk to. I hate that. I've actually written letters to the Stats Association, and they said, well, no one agrees. Don't you hate that? So it didn't help to write a letter to them. The maximum, 40. So the oldest person, okay, is 40 years old of the students. Okay, standard deviation is 7 years old. 7 years, not 7 years old, 7 years. Okay, what that says, one way of thinking about it is that if we look at the mean, it's about 27 and a half. Standard deviation is 7.2 or so, if you round. If we add 27.5 and 7.2, you get 34.7. If you subtract 27.5 minus 7.2, you get 20.3. So that range of 20.3 years old to 34.7 years old, that's like the typical group of people. Do you see that? Kind of majority is going to be in that range, typically. Okay. If I said, what if somebody was, what if we looked at this 40-year-old? Is this 40-year-old an outlier? Okay, the way you do that is you find the z-score for the 40-year-old. So notice the standard deviation. I'm going to use one decimal place. So 7.2 and 27.5. Let me go over here. Oh, let me put all these numbers in so I have them. Mean is 27.5. The minimum was 18. I remember that one. Q1 was 22. And then, sorry, median was 28.5. Q3 was 32. The maximum was 40. And the standard deviation was 7.1. By the way, it gives you some more. It gives you the variance. We're not going to do much with the variance, so don't worry about it. I wouldn't even put it in your project, by the way. I'll never ask you about it. It's a mathy thing, and the math is too hard to really get into. IQR is 10. So that's the kind of the spread of the middle 50% is 10 years old, 10 years. And the sample size was 10 also. So 10 people answered the survey question. Okay, so 7.2. Why did I put standard deviation in highlight with a higher font? Oh, my audio went out. Can you hear me still now? Okay. Yeah. Please let me know if you can't hear me because it's not telling me my audio went out. And internet I'm at the college is usually really good, even though it's blizzarding, so we could lose internet. Hopefully we don't. Why did I put it in red with big font for the standard deviation? Yeah, it's important. It's not just important, it's the most important for this class. You need to really get this down. Okay, so standard deviation is 7.2. It tells you how spread out, okay, the data is. Okay. So somewhat spread out, right? It's kind of a spread of 14 on average years of age. It's a pretty big spread. Okay, by the way, if I did the same survey, oh, we'll get to the secret word. We're not there yet. Still have time. I told you we usually go like an hour and a half or so, sometimes an hour and 40 minutes. So we got a while. We'll get there. So if I, instead of asking you guys, let's say I went to say UC Davis, and I asked a bunch of students in let's say a statistics class at UC Davis, not online, face to face. Do you think the standard deviation would be as big as 7.2? What do you think? And maybe you guys don't know about UC Davis, but I do. And by the way, this is true for UC anything, any of the UCs. Yeah, the answer is it wouldn't be 7.2. It would probably be 1. Okay, and that's because most of the students at UC Davis are really all between 18 and 21 years old. Most people, they get out of high school, they go to UC Davis, they spend 4 years and they get out of UC Davis. And the ones taking stats, they're maybe, freshmen and sophomores. Okay, does that make sense? So standard deviation at UC Davis is going to be a lot smaller than the standard deviation at Lake Tahoe Community College. Okay, if you don't know that, trust me. How's that? Okay, but if you don't understand what standard deviation meant, then that's where you ask questions. Okay, any questions on that idea? And my guess, Braulio, you could tell me, Chico State University, smaller standard deviation Lake Tahoe in terms of age? For age?
Sorry, what was the question?
Chico State has a smaller standard deviation of age than Lake Tahoe Community College?
Yes.
Yeah, so similar. Similar. I think I've only been on campus at Chico State once, and I think it was like during a holiday, no one was there. So I don't know much about it, but my guess is that it's going to have a much smaller standard deviation because the people are all around the same age. Do you see that? Okay. So now let's see if 40 is, let's see if 40 is an outlier. So to do that, I'm going to use a Z-score. And the nice thing is I'm going to copy and paste. I love copy and paste. I remember when I was in college, that's the first time I ever saw copy and paste. I was so excited because computers were new then. And then I'm going to put in the numbers. Okay. 40 is our value. You want to find out how rare that is. Mu is our mean 27.5. Sigma is our standard deviation, and I'm going to use 7.2. Okay. If you're doing this for the homework assignment, online assignment, carry more decimal places than just one, by the way. Carry a bunch. If you're doing it for, your discussion post, that's fine to do just one. But computers tend to be pickier. So then, by the way, I can click scientific calculator, and I put that in all the calculators. And that was 40 minus 27.5 divided by 7.2. And we get 1.7 about. Do you see that? 1.7 means it's not an outlier. Do you remember how big it has to be an outlier? Remember what I said? Remember? Not 3, 2. 2. So at least 2 is an outlier. At least 3 is an extreme outlier. Very, very rare to be at least 3. And 2 is pretty rare too. But so 2 or bigger is an outlier. 3 or bigger is an extreme outlier. And by the way, same thing on the other side of the coin. Less than -2 is an outlier. Less than -3 is an extreme outlier. So either side. In this case, 40 is not an outlier. So there's no old people outliers. And by the way, if I did the same thing with number 18, it gives me -1.3, not an outlier, right? So what I know for sure, actually, is there's no outliers. If the highest isn't an outlier and the lowest not an outlier, there can't be outliers because everyone else is like even closer. Any questions on that idea? Okay. So let me give you some applications. Okay, besides like our age thing, which was just fun. Stock market investments. Outliers are, you want to look at standard deviation. What do they call standard deviation? And some of you might know if you've ever had a business class. What do they call standard deviation when it comes to the stock market or business? It's a 4-letter word. That's a hint. You've all heard the word. It's not a fancy word. I don't know. Okay, let me tell you. Risk. Sorry, someone's at the door. Risk. If it has a high risk, that means it's a high standard deviation because you might lose money. Do you see? It might go way down. Okay. Whereas if it has a low risk, it has a small standard deviation. Okay. And for business, that's really important. So if you have a low standard deviation, that means you have low risk. And by the way, if it's a low standard deviation, you're also not going to make a huge amount of money. You're going to make close to whatever the average percent is. Does that make sense? Okay, so very important. Okay, here's another example. Let's suppose my goal is to have most of the students pass the class. I would love to see that. Okay, and by the way, just remember 70% or higher is a pass. Okay, if the average score, I'm going to tell you last quarter, the average score was 74%. Am I satisfied to reach my goal? What do you think? Okay, let me tell you, the answer is a trick question. You can't know because it depends on the standard deviation. If the standard deviation is 1, I reach my goal because almost everyone is between 72 and 76 because everyone outside that would be an outlier. And that means almost everyone passed. Maybe everyone passed, probably everyone passed the class. Okay. On the other hand, if the standard deviation was 20, okay, and then I could have a whole lot of people that are maybe 68. And then a whole lot of people that are 99. You see? And a whole lot mean 40% 99 and 60% 68 or something like that. Or maybe 20% 99 and 80% 68. The average might be 74%, but almost everyone failed. Do you see? Or got a D. So without knowing the standard deviation, you don't know whether I reached my goal. Okay. So if instead the average score was 74% and the standard deviation was 0.02%, am I satisfied? Yeah, then I'm very satisfied. I know, like, for sure everyone passed, because 0.02%, that would be like 20 standard deviations below to not pass, and 3 standard deviations below is really low. So it's never going to happen. Do you see that? Any questions? Any questions on this? Okay, make sense? All right, so I want to spend pretty much the rest of the time talking about charts. I did Z-score already, I just want to make sure. But because I'm pretty close, not at the end, but I'm getting close to the end. Secret word. Okay, and it's tricky, it's not a word. It's SD. Why do you think it might be? What do you think SD is? Why is that really important for this particular day? Yeah, it stands for standard deviation. But don't write the whole word standard deviation, write SD. I try to make the secret word really important, but something you wouldn't guess. My guess is none of you would have guessed SD if you didn't come to this webinar, but knew that standard deviation was important. You wouldn't think about that. So SD is the secret word. All right, so now that I've shown you that, let's go back and I want to talk about charts. Okay, and let me go, and I forgot to do this ahead of time, but it only takes a moment. Let me go to this calculator, which I showed you last night, I think, just the beginnings of it. And we can even do the same data, 32, 18, 28. So let me just show you a few things. The first thing I'm going to do is I'm going to highlight these numbers, hit backspace, and that just erases them. Because you're going to have to do that for your project, by the way. It's easy to do, and that's it. Then you just type in the numbers. 32, 18, 28. $40, 19, 29. $22, 30, 35, 22. Is that 35, 22? Yeah, 35, 22. Okay. So there's our data. And what I did in the spreadsheet is I coded a histogram. There's lots of available histograms online, to do this. But if you use this one, then it'll give it to you. It doesn't do a whole lot. It just does this. And have you all seen a histogram before? Most people have. You've seen a bar chart. You've seen something that looks something like this. So it's a bar chart. Yeah, it's a bar chart, but notice that the x-axis is numbers, not words. So a bar chart with words is not a histogram. So it's a bar chart where it breaks up into in this case, 15 to 21, 21 to 27, 27 to 33, 33 to 39, and 39 to 45. Okay, and I just used whatever Google automatically did. So that's how I've created this, by the way. And that gives us a bar chart. You'll notice that right here between 27 and 33, that's what we call the mode. Mode means the highest frequency. So for the histogram, that's the mode. By the way, the mode for the individual numbers is 22 because 22 is the only one that actually had two people that were 22 years old. But in terms of the mode for the histogram, that would be the highest bar. We say this as unimodal. You've heard the prefix una in another word. Where have you seen unit? UNI. So you can think of a word that starts with that. It means the same thing for the prefix. You all know it. I don't see y'all jumping in. How about, okay. Yeah, universe is good. University. That one's a little harder one to explain. Let me give you one that is a little easier to understand, and that's unicycle. Okay. Whereas the other big thing that you can ride on besides the unicycle would be that's similar, but it's not the same. That doesn't use una, uses something else. And something that I can ride on easy, where I'm not good with the unicycle. Bicycle. So a bicycle means there's two wheels, right? Unicycle means there's one, right? So unimodal means there's one mode. So we say this is a unimodal histogram. Okay. Any questions on that? So it's a unimodal histogram. Let me show you, I'm going to Google it. Hopefully it'll be fast. I better put in distribution. There we go. This right here is unimodal. And it's not just unimodal, but we say it's a normal distribution. Okay. It's the most important distribution for this course. And we won't understand that until we get to chapter 7. But right now, trust me, it's the biggie. So this is a normal distribution. It's often called a bell curve. In our class, I'll be calling a normal distribution. And if you have a z-score of -1 to 1, that's 68, about 68%. Goes within those two. A z-score between -2 and 2 gives you about 95%, and a z-score between -3 and 3 gives you about 99.7% of the data. And that's a normal distribution. Any questions on that? Okay, very important. Okay, lots of different kinds of distributions. Okay, this is symmetric. Notice the left hand, you get a left tail and a right tail. And that makes it symmetric. If you didn't have this tail here, if you only had a right tail, then we'd say it's skewed right. If you only had a left tail and you didn't have a right tail, it would be skewed left. Any questions on that? Okay, so there's lots of different kinds. By the way, if it's a bimodal distribution, what do you think it would have? This is unimodal. If it was bimodal, yeah, it would have two modes. So an example of that might be kind of the average height, the height of adult Americans. Why might that be bimodal? Yeah. There's a lot of women who are around 5'4" and a lot of men who are around 5'10". And you get those two modes. Does that make sense? So usually when it's bimodal, it means that there's two groups that are kind of being represented in that population. That's typically what happens. Often I'll actually have a bimodal distribution for my grades. A little sad. And that's because there's the students that actually do work. And then there's the students that don't do work. It's sad. I wish it was unimodal with just students doing work. But to be honest, I do get a lot of students who don't do any work. I hate it. So it's a bit sad, but it happens. So that could be, but sometimes my grades are bimodal. And it's not something I do. It's just happens to do the type of student I've got. Any questions on that? Okay, I want to show you, can run out of time, but we stop a little bit. I don't like to go over an hour, 40 minutes is kind of my max. So I got 10 minutes before then I start feeling guilty. If I go to stats and I go to box plot, I want to let you know if you do this, it's going to give you all kinds of warnings on your computer that you might be getting a virus. And you just got to say, no, I accept it. I'll allow it. Won't give you a virus, but usually it gives you warnings. So just a warning. This is called a box plot. Very important. And what this really is sometimes they'll call it the 5-point summary plot. Because there are 5 lines. There's this bottom line. This is the minimum, 18. There's this next to bottom line. This is the first quartile, 22. There's this line kind of not quite in the middle of the box. And that's the median, 28.5. There's this line that's closer to the top. That's the third quartile. And that's 31.5. And then finally, there's the top line, which is 40, and that's the maximum. So this is a picture that shows you those 5 numbers. Okay. By the way, the words at the bottom here, I did that for blind people because by law, I have to make sure that it's accessible. So if you don't have eyesight, you should still be able to kind of hear the box plot and it'll at least give you these things. But if you do have eyes that, if you have good vision, then you don't have to worry about the bottom stuff. But this is a box plot. And notice that the middle 50% is between 22 and 31.5. Okay, years old. So very easy to read that. The biggest problem with the box plot is if you show this in a presentation to a bunch of general audience people, most of them will have no idea what you just showed them. Okay, but if you show the box plot to a bunch of people who are educated, college educated people, then most of them do know it because it's a standard thing. Every stats class has it. It's also now given standard in high school. So those of you who are just out of high school, you've probably seen this. Those of you who have been more than 5 years since you've been in high school, you didn't see it in high school probably because it's a new thing in high school. So, and if you didn't see it, if you're 18 years old and you didn't see it in high school, your teacher screwed up, just let you know, because they're supposed to show the statistics, certain statistics, and this is one of them they're supposed to show. Any questions on a box plot? Okay, and the last plot to show, if I go to stats and I go to stem and leaf. This is called the stem and leaf plot, or the stem and leaf diagram also. And again, don't worry about all this. This is to make it so that if you don't have eyesight, you'll still be able to read it and understand it. This is really what's important. What this does is it gives a nice depictive view of the data, and you don't lose the numbers themselves. So we could see that it's unimodal. Do you see that? And it breaks it up. So in the 20s is the most common age. That's the mode. Do you see it? So it's kind of a weird form of a histogram, but it has all the numbers. But it also says that there were 2 people that were 22 years old. There was one person that was 19. See this 1? That's the tens digit. See this 9? That's the ones digit. So 1 and 9 is 19. Whereas 1 and 8 is the 18-year-old. And here we have a 22-year-old and another 22-year-old. So what a stem and leaf diagram does is it allows you to be able to see a histogram type of thing and get that kind of vision and shape, and you don't lose your data. Any questions on the idea? One of the big problems with the stem and leaf is it's terrible if you have a data set of 1 million. Because you'd have to have 1 million numbers written here, and it wouldn't fit in anything that you'd ever show. So it doesn't work well for very large data sets. Does that make sense? It also doesn't work with 1-digit numbers, because then you don't get a stem and a leaf. So it works well with 2-digit numbers. And by the way, the histogram, the box plot, and the stem and leaf, those are going to be 3 things that you're going to have to do on your project. So make sure that when you do your project, that you get enough answers that are 2-digit numbers. Otherwise, your project won't work. You won't have a good stem and leaf. Okay, just a note. I like to say things about the project as we go. Okay, and so basically today, pretty much everything you have to do in the project I talked about today, but I don't have enough time to go over the project because I have too much to talk about today. Any questions about a stem and leaf diagram? Any questions? Okay, so we looked at diagrams. There's others, and I'll let you watch the long video to see others. Again, I don't have time to show you everything that could ever happen. I do main points. Okay, and you can read the chapter and get, some more examples, but I can only do some. At least I've done the ones that you have to do for the project. Okay. Let me give you one last little example. Suppose you're in a hospital and you're taking care of an infant, a little baby, okay? And the z-score of weight is negative 3.7. What will happen to the child? The baby was just born. Z-score is negative 3.7. What will happen to that child? Yeah, ICU. Okay, that child will be put instantly in ICU because that child is a extreme outlier under -3 in low weight. Does that make sense? Okay, so that child needs help. So in medicine, it's very important to understand z-scores. Okay, another infant had a z-score of 3.1. What do you think is going to happen in terms of that birth process? Remember, this infant was just born. And you may not know, but you may if you know anything about, giving birth. Okay, hard birth for the mother, and in terms of the hospital piece, that's going to be a C-section. That baby's way too big to naturally come out without endangering the mother. Does that make sense? Yeah. So that would be where the mother needs help, not the baby. The baby will probably be healthy, actually. Big fat baby, but that's okay for babies. The little babies aren't as good as big babies when it comes to health. Okay. A third infant was born with a z-score of negative 0.19. What can you say? Yeah, that's your average baby. That's going to look like any other baby that you're used to seeing. Does that make sense? Nothing especially noticeable in terms of weight. Any questions on this z-score idea? Okay, I like to give you real things. All right, it's 1:39. So I am going to say we're done. I'm going to stop the recording. Doesn't mean you can't ask questions, but I'm going to stop the recording. Always takes a moment to do that.